The lesson topic for this video is, I can find 6 trig ratios using a point. So, yes, I did say 6 trig ratios. There are actually 6 trig ratios, even though we have always known only 3 of them. Okay, we've known sine, cosine, and tangent, both in geometry and in algebra 2. But now there are 3 additional trig ratios. There are cosecant, secant, and cotangent. Now, each of these 3 new trig ratios is the reciprocal of one of our old trig ratios that we already knew. So let's start by writing out what our trig ratios are for sine, cosine, and tangent. So sine, you should remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And the tangent is the opposite over the adjacent. So, if I said that the other 3 trig ratios are reciprocals of the ones that we've already talked about, we just have to make sure we're matching up with the correct one, and then we can just use the reciprocal of the fraction, and that would be the new trig ratio. So, sine and cosecant are reciprocals of each other. Cosecant is abbreviated with CSC for cosecant, and therefore cosecant of theta is hypotenuse over opposite. The cosine and secant are reciprocals of each other. Secant is abbreviated SEC for secant. So the secant ratio is hypotenuse over adjacent. And lastly, cotangent and tangent are reciprocals of each other. Now these 2 are pretty obvious because tangent and cotangent kind of makes a lot of sense there, right? And so if we take the reciprocal of tangent, so adjacent over opposite, we have cotangent, the cotangent ratio, which is COT. Now, the thing that is actually a little tricky here is that you might think that cosine, C-O-S, cosine, and cosecant would go together, and they don't. They are not reciprocals of each other. And that's, I guess, just a way you could remember it is that the 2 that you'd think would go together, cosine and cosecant, don't. Tangent and cotangent do, cosine and cosecant don't. So then maybe it would remember that sine goes with cosecant and cosine goes with secant. Okay, so in this diagram here, all we are going to do is write the 6 trig ratios or trigonometric ratios for theta. So here is our angle theta. Before we get started listing all the trig ratios, we should for sure label our sides. So remember that across from the right angle is the hypotenuse. So I'll label that HYP. And opposite of the angle that we're talking about, so if this is the angle we're talking about, opposite, the opposite side is the side with 8 here, so that's opposite. And that leaves the third side to be the adjacent side. All right, so let's list our 6 trig ratios. We have sine, cosine, tangent, cosecant, secant, and cotangent. Sorry about that, and cotangent. So if I want to take the sine of theta, I know the sine of theta is the opposite over the hypotenuse, so 8 over 17. The opposite side over the hypotenuse. Now, if we wanted to jump right down and do the reciprocal trig ratio, the reciprocal of sine is cosecant. So if we wanted to write the cosecant ratio, we could simply take the 17 and the 8 and switch their places for the reciprocal. All right, jumping back up to cosine, cosine of theta. Cosine is adjacent over hypotenuse, so the adjacent side is 15, the hypotenuse is 17. Which trig ratio is the reciprocal of cosine? Well, secant. So we know that secant theta is going to be 17 over 15. And then lastly, we have the tangent. Tangent of theta is the opposite side over the adjacent, and that's 8 over 15. And therefore, the cotangent for theta is the reciprocal of 8 over 15, which is 15 over 8. Again, these are our original 3 sine, cosine, and tangent ratios, and the 3 new ones are the reciprocals of those. Sine, the reciprocal is cosecant; cosine, the reciprocal is secant; and tangent, the reciprocal is cotangent. Okay, so for these examples, we are going to say that given a point on the terminal side of theta, which we've been working on drawing those angles, we're going to draw the angle in standard position, and we're going to show the rotation with an arrow. We're going to label theta prime, which you'll recall is your reference angle, and that reference angle is always created with the terminal side of the original angle and the nearest x-axis. Then we're going to sketch the right triangle using the theta prime as our angle, and we're going to write the 6 trig ratios for theta prime. So it's kind of putting everything together. So first we're going to put the point -4, 13 on our coordinate plane. Sorry, I got distracted there. -4, 13. So -4 on the x-axis, 13 on the y-axis would probably be somewhere around here. -4, 13. We're going to draw the angle in standard position that has that point on the terminal side. So there it is. We're going to label this as theta, our original angle. Then we're going to label theta prime. Theta prime uses the terminal side of the original angle and the nearest x-axis. Well, this is not the nearest x-axis. This is. Remember, this is the y-axis. So here is the angle that we need right here. So I'm going to put theta prime right here. Then we're going to sketch the right triangle that is created by using that theta prime angle, which means I'm going to bring this down like so and put a right angle mark there. And now we're going to write the 6 trig ratios for theta prime. Now, in order to write the 6 trig ratios for theta prime, we need to find the measures of the sides of this triangle. And the thing is we already know 2 of the 3 sides. We're going to need to find the third. Can you think for a minute of how you might know the length of this side of the right triangle? Here's a right triangle. How do we know this length right here? Well, we know that length because of this value right here, -4 on the x-axis. We had to go -4 along the x-axis and then 13 up. So we know this length right here is 4 units. Now remember, it's not -4 because length is never negative, so it's +4. Then from there, we had to go up to 13 on the y-axis, so we know this side here is 13. Now in order to write the sine ratio, which is part of what we're going to do next, right? We're going to write the trig ratio. So in order to write the sine ratio for theta prime, we need opposite over hypotenuse. Well, the opposite side from this angle is 13. The hypotenuse, however, is over here, and we don't know that yet. So how do we find the length of the hypotenuse right here? Well, we use the Pythagorean theorem. So I'm going to go ahead and use a squared plus b squared equals c squared. And the hypotenuse is what I'm looking for, which has to go in for c. So I can leave that as a c, or I could put in an x there, whichever works best for you. And a and c are the 4 and 13, and it doesn't matter what order we put those into our equation or formula. So 4 squared is 16, 13 squared is 169, equals c squared. 169 plus 16 is 185, so we have 185 equals c squared, and we know we need to square root both sides to find our answer. Now, just so you know, in this unit, after we square root here, after we square root right here, we can actually leave our answer in square root form. So our answer, unless it's a perfect square, then you should simplify it. But this means that c is equal to the square root of 185. We're going to go ahead and write that in here, square root of 185, instead of getting decimals. That is fine. So now we're ready to write the sine ratio for theta prime. I would actually go through and label my sides first, so I'm going to go ahead and do that based on the right angle. This is the hypotenuse. The opposite side for theta prime is over here, and the adjacent is right here. So now we are ready to write, for example, our sine ratio for theta prime. We have to remember our ratios. Sine is opposite over hypotenuse. The opposite of theta prime is 13, and the hypotenuse is the square root of 185. Okay? Cosine of theta prime is the adjacent, which is 4, over the hypotenuse, which is 185. The tangent of theta prime is the opposite over the adjacent. Now, the reciprocal of sine, remember, is cosecant. So the cosecant of theta prime is the reciprocal of sine, so square root of 185 over 13. The secant, which is the reciprocal of cosine, is square root of 185 over 4. And lastly, we have the cotangent of theta prime. Cotangent of theta prime will be the reciprocal of tangent, so 4 over 13. And those are 6 ratios for this diagram. Okay, for practice, I highly recommend that you, at this point, pause the video and do the same work that we just did on the left for the point -8, -12. Okay, so we start same way. I'm going to put my diagram up here to give myself a little more room. We start by plotting the point -8, -12. -8, -12 is right around here. Draw the angle in standard position and continue from there. Pause the video and then come back to check to see if you got those trig ratios correct. Okay, so here are the ratios you should end up with. You should have had a hypotenuse of the square root of 208. And let me know in class if you have any questions.